Hi, Chapter 10 is next on deck here. Reasoning and problem solving is essentially a topic that is a direct continuation of the judgment and decision-making content that we covered in the previous chapter here. Little difference is that the reasoning stuff here is going to focus quite a bit on deductive reasoning and inductive reasoning. And we're going to understand some questions here about how well can people engage in these types of reasoning. And with problem solving, well, we'll see what that is, how to solve specific kinds of types of problems here. All right, let's start though with deductive reasoning. So defined here as reasoning from a general principle to a conclusion about a specific case. So um, when let me, I have the class have well, I have a syllogism here, but I didn't put the classic syllogism on the slide. So this is like Intro Philosophy 101 or Intro Logic 101. The syllogism usually has the form of saying all men are mortal. That's a general statement. Socrates is a man, therefore Socrates is mortal. So we go from that general premise, all men are mortal, down to a specific conclusion about a specific person here. And that's called a syllogism, right? It's a couple of premises and then followed by, right, if it is true that all men are mortal, and if it is true that Socrates is a man, then given those two premises, the conclusion must hold to be true deductively, right? Going from those two general statements, right? Why are they general statements? Because we're making a statement about all people here, all men are mortal, and that we're also saying that Socrates is a member of that category. So therefore, that's a statement that refers to the general category. And so now we will apply to the specific case, and that's our conclusion. So on this example, I have a slightly more maybe updated version, right? All social media platforms require internet access. That's a broad general statement, a premise, right? TikTok is a social media platform. Again, that's suggesting now that TikTok belongs to this category. Therefore, TikTok requires internet access. So one of the reasons why we might like this one, besides being a little more up to date, is it points out a couple of things. Number one, as I have written here on the slide, when we follow the rules of deduction, that means that if the premises are true, then the conclusion is true. When we don't follow the rules, we've committed a fallacy. But what's really important here, and this is actually very important, is that whether or not the conclusion is true or false is somewhat independent of whether the conclusion is valid given the premises, right? Let me say that again. The truthness or falseness of the conclusion is partially independent of the validity of the argument. So what do I mean by this? So the syllogism that I have written on the slide about social media platforms and TikTok is in fact a valid argument. But notice the phrase here, if the premises are true. So the next question is it really true that all social media platforms require internet access? Well, it might be true, but the point is that if it's not true, that means my conclusion is false, perhaps, right? Because it might be the case that I could get on TikTok without internet access. I don't know. I don't use it. But the point here is that the validity of the argument, when you consider as a standalone argument, given premise one and premise two, does conclusion follow from the two premises? The answer is yes. Deductively, the conclusion follows from the premises. That doesn't mean the conclusion is necessarily true. That also depends at least on the truthfulness of those premises. And if those are not true, I could still have a valid argument that results in a false conclusion, right? That's what I'm trying to point out here. And by the way, it's also possibly true that I could engage in fallacious reasoning in which I actually have an invalid conclusion. Given my two premises, I have reason to a conclusion that doesn't really follow, but it still might be true. right? And so this is where things might get weird. So let's look at some fallacies, right? Um, and so, well, first off is not a fallacy necessarily, right? So this is called modus ponens, right? So modus ponens is a type of deductive argumentation that takes the form of an if-then statement. So it's a simple if-then logic. And we use P's and Q's here as a shorthand for just kind of a holder for whatever our statement might be about, right? So again, if TikTok is a social media platform, then it must require internet access, right? That could be a P and a Q, right? But it doesn't matter what the details are, right? We're just going to use the P and the Q here, right? So that's called modus ponens, right? Now, what's also true is there's a variation of it called modus tollens, then which is called, well, which phrased here, if not Q, then not P. So the argument here is that if we accept the modus ponens claim, if P then Q, as a true statement, this would also suggest that its inverse is also true. That is, the absence of Q implies the absence of P. So again, above with modus ponens, if TikTok is social media, then it requires internet access, if P then Q. So then if we say that if TikTok does not require internet access, so if this now is a not Q, then of course it follows that it is not social media, assuming our original premise is still being adhered to, right? So the point here is that if I say if P then Q is true, then it is also the case that if not Q, then not P. So a little bit of a logic exercise there. Bet you weren't expecting that, but these are valid deductive claims, right? Now let's look at the fallacies. The first fallacy is called denying the antecedent. So again, we're going to use our P's and Q's here. As they say, we're going to mind our P's and Q's. Where does it come from? We need to make sure that we're thinking logically. So if I say it is true, if P then Q, is it also valid for me to say not P, therefore not Q? Well, it gets a little bit difficult, of course, when we try to use our P's and Q's. Maybe it's a little more clear when we use these examples again. So if P, then Q. If someone is using TikTok, they have internet access, right? We're assuming then those two things, that's a true thing, right? So if P then Q part is true, is it also does it also follow to say not P? This person is not using TikTok. Therefore, they do not have internet access, right? And it's this new thing that I underlined there, the not P part, that's critical here. So just because the person is not using TikTok doesn't mean they don't have internet. Maybe they just don't like it, right? So that means that we have denied the antecedent. In this case, P is the antecedent, right? And we're denying the antecedent. But does denying the antecedent have any necessary impact on Q or not Q? And the answer here is no, right? It does not, right? We can't say not Q just because of not P here. A couple of other examples here. If King Charles is an American citizen, then he is a human being. That's presumably true. You have to be a human being to be a citizen. King Charles is not an American citizen, therefore he's not a human being. Again, denying the antecedent has no impact on Q at this point. If it is raining, then the ground is wet. It is not raining, therefore the ground is not wet. Again, we've denied the antecedent, but it does not follow that we should say not Q, right? So these are fallacies, right? This logic does not hold. Besides denying the antecedent, we can also affirm the consequent as a fallacy as well. So P is the antecedent, Q is the consequent. So again, if I say if P then Q is true, is it also the case that if Q then P, or Q therefore P as I wrote it here? So again, if P then Q is framed as if someone is using TikTok, they have internet access. And so now let's affirm the consequent. Q, this person has internet access. Does that mean therefore they're using TikTok? No, of course not, right? So affirming the consequent Q does not necessarily mean that P is also present, right? Even though P affirms Q, Q does not affirm P, right? And the other examples here, if I have the flu, I'm going to have a sore throat. I have a sore throat. Does that mean I have the flu? No, of course, there can be other reasons, right? And if I own Microsoft, then I'm rich. Yeah, I'm rich. No, I'm not. Therefore, I own Microsoft. Clearly, no, there could be other reasons. So again, we see why affirming the consequent is not a valid logical claim, right? It's considered a fallacy. These are called conditional fallacies because, again, going back to our modus ponens and modus tollens, these are all cases of what are called conditional logic, and fallacies of which are then called conditional fallacies. There are other kinds of fallacies here. So these are also reasoning fallacies, so we can list them here as well. You may have heard of the first one, an ad hominem, or ad hom for short, sometimes when we don't want to write it all out. That is Latin for against the person. And the idea here is that if I want to challenge what someone is saying, then if I want to be reasonable and logical about it, I need to challenge them based on the content of their argument, right? To critique the truthfulness and validity of their claims. But if I just challenge their character or something along these lines, right, then I'm attacking the person and not the argument. So if person A says, I think smoking is bad for you, um, and person B says, well, yeah, but you work for the cancer group or whatever, you make, and who all make money by saying this or whatever. Again, you're challenging the person and not the substance of their statement, right? We also have the fallacy called begging the question, which is sometimes kind of treated as essentially the same thing as a circular argument. So, if I say paranormal activity is real because of ghosts and ghosts are real, then again, I haven't necessarily proven anything, right? It's kind of the same thing twice. And if I say that, Audi has the best cars because they're the best cars, right? That's not an argument for anything, right? Or a slippery slope, right? And so the idea here is that it's a common thing that we might see sometimes is that people start to say things like, well, if we let this happen, then this is going to lead to another thing and another thing and another thing, and we'll go down that slippery slope where it leads to catastrophe later on. Could be true, but it doesn't necessarily, it's not guaranteed. It's not logically guaranteed. So if someone's complaining because, say, your university wants to raise tuition, then we have to say, oh, we can't let them do that because they do it one time and then they're going to do it again and again and again. And pretty soon they're going to be charging some insane amount of money per semester. Again, it might be true, but there's no proof of it. It's not a valid argument to actually make this claim that we're going to move down into that direction. Right. Now, what I want to get back to here, now that we've sort of defined our valid arguments, deductions, and conditional logic, and our invalid versions, right, our various fallacies, what I want to talk about here is, as I said at the beginning, that the truthfulness of a claim doesn't necessarily exactly follow from the validity of the argument because it also depends on the truthfulness of our premises. So just as a reminder, I can have a true premise, but if I can commit a fallacy, then I might have a false conclusion. I could have a true premise and commit a fallacy, and I might still have a true conclusion. Why? Let's go back to one of our fallacies, for example. Let's look at the bottom one here. If it is raining, then the ground is wet. Okay, that's a valid conditional statement. It is not raining, therefore the ground is not wet. Well, that's a fallacy, right? It is the denying the antecedent fallacy. But is it necessarily false? No, it very much could be the case that it's not raining and the ground is not wet. So it could be a true statement, but it is simply not a logical statement, assuming it's meant to follow the first statement, right? And so that's where we need to separate the validity of the argument from the truthfulness of the argument. And this is where things get tricky. And if you're thinking it's tricky now, that's actually normal because the point of this research is to show that people's judgments of the validity of an argument, if that's what we want to do, if we want to show them some types of examples of some arguments here and ask them to judge its if whether it's true or not, whether it's believable or not, their judgments don't necessarily align to the actual validity, but it also aligns to the truthfulness and believability of the conclusion here, which suggests then that when we are judging the quality of an argument, we're not necessarily always working just on the quality of the argumentation and whether they followed, say, a modus ponens or modus tollens or anything like that, but rather we are also letting our own beliefs and our attitudes and what we think is true influence our judgments here. So here what we have are four possible combinations here. Let's say I design some syllogisms or conditional logic statements that are valid and believable. But I'm going to ask people to just judge the validity, right? Not whether it's true, not whether it's believable, but just is this a valid argument? I can also ask them to judge a valid argument that is also kind of leads to an unbelievable conclusion. I can also set up conditional statements that are invalid but lead to believable conclusions. And I can also set up statements that are invalid and lead to unbelievable conclusions. And so what do our data look like here? Well, let's not, before we get to the data, let's look at some examples. That'll be helpful, right? So what are valid but unbelievable claims here, right? So let's start with this syllogism. No addictive things are inexpensive. Some cigarettes are inexpensive. Therefore, some cigarettes are not addictive. So as a syllogism, this is perfectly valid, right? If we accept the first two statements, our conclusion, some cigarettes are not addictive because they're not expensive. And if they're not expensive, then they're not addictive, right? So that's valid, but of course it's not believable for us to think this, right? It seems to just violate everything that we think we know about that. So what are we going to say? Is this a valid argument? Yes, it is, but what do people actually say? Let's go to our data here. So in this graph, the bar chart represents the percentage of people who judge it to be valid. So when it is in fact valid and believable, that's our blue bar here on the far left, 90% judge it to be valid. But in a case of that I just showed you about the cigarette example, it is valid but unbelievable. And now we're down to 50% only think that it is a valid argument here. So the difference between the two arguments is not their validity, right? But it's the difference in their believability of the conclusion. And that seems to be driving a strong decrease here in validity judgments. So let's go back to the other case here. Invalid but believable. No addictive things are inexpensive. Some cigarettes are inexpensive. So what are we doing? We are affirming the consequent. Therefore, some addictive things are not cigarettes. That sounds like a believable conclusion, right? But because we have affirmed the consequence, this is not a valid argument here. But do people judge it to be valid? Yeah, 90% judge it to be valid. And when it's invalid and unbelievable, of course, you get the expected 10%, why isn't it zero? I guess not everyone necessarily understands logic, but the idea is this effect shows here that when we have a valid argument, it can still be valid but unbelievable, and people may not accept it. And likewise, if we have an invalid argument, if it leads to a believable conclusion, people may very well accept it. So I think that's worth knowing in general, that this is how people will judge the conclusions, right? They're influenced a bit by the validity, but also by the believability of the conclusion and whether it matches what we expect to be true. Do we want to call this a confirmation bias? We might, right? Because it might suggest to us that because I already hold this particular belief, then what appears to be an argument that supports my belief will be something that I can accept here, right? But that's the claim here. People are using a combination of beliefs and logic during these tasks. And so in this case, maybe people can't necessarily label all of the details of the logical rules, right, of actually like mapping out modus ponens and modus tollens. But they do at least have some ability to distinguish valid and invalid arguments. But again, the believability is going to factor into this a little bit as well. Right. Now, the next section focuses on the exact nature of our experience and the knowledge that we have. And this would also further suggest then that what we know also influences how much we can reason about this sort of stuff. Um, let's just get into an example. I think this will make it clear. So first we have what is called the Wason card selection task. And so here is what we have. We have 4 cards. On one side of the card are some numbers, and on the other side of the card are colors, right? So what we're shown is what we have on the screen here. 2 of the cards are turned with the number side facing up, so we see the numbers 3 and 8. And 2 of the cards have the number sides facing down, so we see the colors and we can see a red and I guess that's a brown, right? So here's a rule that we are told that applies to these cards. Suppose the following rule is true, that all cards with an even number have a primary color on the back, with primary being defined here as red, green, and blue. So that would suggest, of course, that the number 8 has a primary color if this statement is true. And then, so which cards should be turned over to test the truth of the rule, right? So one of the things that we see is that, well, the 8 is one that we probably want to turn over here because we would expect it to have a primary color on the back. So that would test the rule. What about turning over the 3? Would that help us? Actually, that is no, because that would be that would be denying the consequent, I think, right? I'm going to get myself tripped up there because we don't know the rule about even number or odd numbers. Sorry, we only know the rule applies to the even numbers, right? And so the subjects though will say that yes, let's turn over the red because we want to check. Or sorry, let's turn over the 8 because we want to check make sure it has a red, green, or blue on the flip side. But they also pick the red, right? And because they say, oh, that's a primary color, so I want to make sure that I flip that over and see that that has an even number, right? But that is not necessarily the case, right? Odd numbers can also have a primary color. That hasn't been ruled out by our rule. It only applies to the even numbers. So choosing to turn over the red card is an example of the affirming the consequent fallacy, right? Turning over the 3 would be denying the antecedent, right? So what you really need to do is you need to choose 8 because that's the modus ponens, and then you need to turn over the brown card because that's the modus tollens, right? If not primary, if not Q, then not even or not P on the flip side, right? So that brown card should have an odd number for sure, right? But people don't pick that. So mildly challenging tasks that many people perform incorrectly. By incorrectly here, meaning that the choice to turn over 8 and red is not really logically valid as a way of determining the truth of the rule that we've been told. Now, you might think, okay, fine, people aren't rational again. But one of the things that may be problematic about this task is that it involves a pretty unusual relationship here between colors and numbers. It's a little artificial. It's a little bit of a setup. It might be just a little challenging and abstract to even think about it. So let's change the nature of the task a little bit here. What if my cards, sorry, instead of having some arbitrary relationship between colors and numbers, what if it has relationships that are more real world in nature? So use my own name here. Suppose the following rule regarding the cards shown above. Children in the McConnell family must refill the gas tank when borrowing the family car. So each card represents one of 4 children. So the 2 on the left represent states about borrowing the car. They either borrowed the car or did not borrow the car. The flip side would be about whether they filled the tank or not. So the 2 on the right have that side facing up. They refilled it and they didn't refill it. So which ones do we want to use? Well, obviously, the rule is about if P, then Q. So if P is the borrowing the car, and so that should lead to the Q of having refilled the gas. So we want to check that. And we also know that from the modus tollens that if not Q, then not P. So, okay, that means if they didn't refill the tank, we just need to find out if they borrowed the car or not. Because if it says borrow the car on the other side, we know the rule is not working, right? And so in this more kind of what we could say is a real life, everyday kind of reasoning example, obviously modified this one a little bit to, with my own name in there, but this kind of equivalent of this has been used in research side by side with the Wason card selection. And while people make a lot of mistakes with the Wason card selection, when they are presented with equivalent kinds of framings that use these real life kinds of situations, now we see their performance is actually rational, right? And it follows the rules of logic. So what this would tell us then is that people can follow the rules of logic here, right? But what's really also happening is that it's hard sometimes, and it works better when we're working with information that we have a solid grasp of the meaning of it, and then we can think better about it, think more logically about it. Our next thing we want to say here, yeah, I got a couple of slides left for this particular video here. So what I want to say about this part of it here is this conditional logic can also be framed as a form of causal reasoning, right? It's reasoning about cause and effect. So if I'm saying if P then Q, what I'm also sort of suggesting here is that P is the cause of Q. And so if P is present, Q will be present because they have a cause and effect relation. So we're saying P causes Q. So it's essentially the same logic you learn when you're in research methods and you learn about independent and dependent variables and manipulating the independent variable, and you would expect to see systematic change in the dependent variable. It's this kind of conditional logic that is causal in nature that allows you to even establish causality in the experiment, right? But what we also learn in research methods is that two things can be correlated, and that doesn't mean they are necessarily causally related to each other, right? As you know, the old adage that correlation does not prove causation. And that happens because you can have two things that are correlated purely by accident, right? Purely by chance. These are called illusory correlations or spurious correlations. And of course, when you've had a course like this, it seems like almost everyone generally understands. I understand why, but that doesn't mean that in the real world, people don't sometimes fall victim to assuming that because a certain correlation happens in reality quite often, that they might start to believe and assume that these two events have some direct causal relationship to each other. So that's a relevant thing to understanding how people respond to, say, information in the news. Next thing to say here is about counterfactual reasoning, right? So part of the issue of the cause and effect argument here is, as I said, we learn this in research methods when we're doing an experiment where we learn about the independent variable and dependent variable. And so when we frame, if I'm doing an actual experiment and I set up a hypothesis where I say that I believe P causes Q, then my hypothesis is also framed in terms of if I manipulate P, then I expect the following result on Q, right? And that's a what if statement, right? Because before I ever conduct the experiment, I'm essentially asking, what if I do this? Then I should expect to see something happen, right? And it's this kind of what if, or this, it's called counterfactual reasoning. Well, why is it called counterfactual? Maybe I should explain this. Counterfactual seems to imply that it's not true, it's against the facts, right? But counterfactual is also a kind of a way of describing statements about things that we haven't yet observed and therefore haven't actually happened yet, right? So the fact that I can imagine what would happen even in the absence of seeing it happen and seeing what the exact outcome is, I can still make statements and predictions about those outcomes, right? So our abilities here to think in those abstract terms, in terms of these counterfactuals and what if type statements, does in fact directly influence our likelihood of understanding the correlation causation relationship here. So the short answer here is that again, beliefs and what we know, our level of knowledge influences our ability to engage in valid reasoning as well, right? Of course, broadly speaking, what this also means is that we're not necessarily always great abstract thinkers, right? That Wason card selection task is a pretty abstract task compared to the one about borrowing the car and the gas tank, right? So the long and short of it here is that when the tasks are very abstract, sometimes performance is challenged, right? And by the way, we can imagine this in simpler terms, which is that when you take a class that deals with really complex abstract things like a high-level philosophy class or a really high-level abstract math class, it's not it's not like doing arithmetic in kindergarten, right? That's very concrete, but this other stuff is really abstract, and not everyone can do it or do it well. So yeah, we're not always great at that very high level of abstraction. And yes, we're not perfect with deductive logic because we know people aren't perfect in general, and therefore beliefs and believability and expectations all are going to influence our judgments of the validity of an argument. Okay, the next part of this is inductive logic. I think we'll stop it here and we will save. We've got deduction here. We'll have induction in the next video. As always, let me know if you have questions.